Okay, now I'm going to teach you how to write formulas for the binary ionic compounds. We've been doing a lot with turning formulas into name. We're just going to go the other direction. And to do this, you really have to have a good handle on oxidation numbers. If you're having trouble with oxidation numbers, there's a good review of how to predict oxidation numbers for representative elements in the periodic table in the next video down. It also has some more examples of how to do this, but I'm going to show you a few simple examples. You might want to pause right now and grab a sheet of paper and kind of jot this down, or you can keep looking at this. I'm just doing this with Explain Everything, the whiteboard, same whiteboard program I use if we were face-to-face in class. If you have questions and you think the whole class may be interested, remember there is a discussion thread at the top of this module that you can ask those questions in. So anyway, let's get started. We're going to start with lithium iodide. Let me grab a pen. And what we're going to do is we're going to write the chemical symbol for lithium with its oxidation number. It is a group 1A element, so it is going to have a +1 oxidation number. We're going to do the same thing with the anion, iodine -1. It's in group 7A. It's a halogen, so it always forms -1. Now our next step is going to be to look at the oxidation numbers, and we see we have a +1 and a -1. That adds up to 0. Ionic compounds are always electrically neutral, so all we have to do to write the formula is to write LII. Your capitalization is very important. You have to use the capitalization that's on the periodic table, which is the first letter of the symbol is always uppercase. If there is a second letter, like there is with lithium, it is lowercase. And that lets us know where one atom stops and another atom starts in these formulas. So let's do the next one, radium oxide. Radium is an alkaline earth metal, and it's not B, it's an R. And this eraser's not working for me this morning. So Ra is +2. Oxide, that's oxygen. Oxygen is always -2. It's a group 6A. Remember, it needs to gain 2 electrons to have 8. That adds up to 0 also, +2 -2. And we're just going to write RaO. We're doing remember, these are formula units. They are the simplest whole number ratio of the atoms in the formula. Let's go to boron phosphide. Boron is group 3A. Column 13, symbol's B, and it is a +3 ion. Phosphorus is 5A. They form -3 ions. And again, we're adding up to 0, +3, -3. So our formula is simply BP. Okay, we're going to do one that's a little bit more complicated now. We're picking up lithium again. Remember, it's +1. Nitride, N. That's in the same group of phosphorus, so it is a -3, so they don't add up. We've got to do a little something to make the electrical charges add up. And there's a very simple way to do that without doing any math. All we do is we do a crossover or a crisscross. What I'm going to do is I'm going to bring the oxidation number from a superscript on the cation down to a subscript on the anion. I'm going to drop the sign, and I'm going to do the same thing here. So I've got Li3N1, and now I just clean it up. We get rid of the negative sign because you can't have a negative number of atoms. So it becomes Li3N. So if we looked at the oxidation numbers, just to check what we're doing to show you that this works. Remember, nitrogen is -3, lithium is +1, and we have 3 of them. and that's going to add up to 0, so we're good. All right, let's do it. Strontium phosphide. Strontium is +2. It is in group 2A. Phosphorus, again, is -3. Doesn't add up. So we're going to cross this over. And what I forgot to mention on the last example, if the subscript is a 1, we don't write it. We just assume it to be there. So let me cross these over. We're going to bring the 2 down to here. We're going to bring the 3 here. And we'll clean this up as SR3P2. Aluminum sulfide, Al is +3. It's in group 3A. Sulfur is the same group with oxygen, so sulfur is a -2. Does not add up. So we're going to cross it over. And it's going to be Al2S3. Okay, ones that are a little bit more complicated, but not really. The next 2 examples have transition metals, and what do we do with transition metals? Well, we can't predict their oxidation numbers from the periodic table. That's why we got the Roman numerals, why we bothered to write the Roman numerals. So copper 2 we know is Cu+2. We're getting that from the oxidation number. And bromine is group 7A. It is -1. Doesn't add up, so we're going to cross the numbers. And it's going to be, it is going to be CuBr2. And I forgot to put an R over here. Yeah, that's good. And now the last one, lead 4. Lead's not a transition metal. Remember, tin and lead have to have multiple oxidation numbers. So we are going to have to take that into account. This is lead 4. Oops, I don't know what I just picked up, but it didn't work. So this is +4. +4, and then we're going to have phosphide. Phosphorus is P-3. We got to cross that over, doesn't add up. So the formula is Pb3P4. Those are all the examples I have. If you need to go back through and look at this, feel free to do so. There's also right below this, as I mentioned, there's a video that goes through, reviews oxidation numbers, and gives more examples. She doesn't do the crisscross quite as graphically or as messy as I do, but she's doing kind of the same thing. So if you need a little help, watch that video. And then when you're done, there is a little, and I'll put it in quotation mark, quizzes. It's just practice. You have multiple attempts. Just go ahead and go through it till you get it right. It doesn't take that long. I will say it's a little cumbersome because the answer boxes won't let you do subscripts. So you just have to type. There's an example of how to type it right down below this. Good luck. Thanks.